You're probably familiar with the concept of AI hallucinations. A bot making stuff up is obviously not good. And when it comes to your business or a business that you're supporting, these unintended results can cost you money, they can do damage to your brand, and in the worst cases, even do harm. Now, luckily, Botpress is well equipped to prevent these adverse hallucinations. And in this video, I'll highlight 6 features, workflows, and best practices to keep these hallucinations at bay and ensure that your bot keeps a firm grip on reality. Let's dive in. All right, we've jumped over to the Botpress studio, and here we have a very simple customer service bot for a fictional clothing boutique called The Hanger. This is just one autonomous node with a pretty strong prompt and access to a bit of information in its knowledge base. I'll be explaining all that in just a couple minutes, but this is a bot you can chat to and ask a bit about this clothing store that we have made up. What's for sale? Cool. Looks like we got some stuff for sale. And this bot itself, how it works is not super important. I'm just going to be using this example as a way to show off a bunch of the different features we have in Botpress that will help you deal with hallucinations and make sure our bot stays on track. Speaking of that, our first feature is over here at the Agents tab on the left side, and we're going to be using something called a policy agent. If you don't know these agents, they're not all enabled. You don't actually need all these agents all the time, but the policy agent is a really nice thing to know that exists in Botpress. And what this is basically this extra level of LLM processing that you can put on top of every single prompt that your bot responds to a user. Now, whatever policy you put into this box, your Botpress bot will be observing that policy across all of its communications. So you can use this in a lot of different ways. In a basic way, we can always just write in here, don't make stuff up. And as simple as that sounds, that actually does help a heck of a lot. But you can also use this to make sure that your bot is following your company's compliance guidelines or legal rules, or even as low level as making sure you're not saying off-brand words or mentioning your competitors' products. Now, off camera, I've cooked up this policy description. This is just a natural language, so just written word. You can basically describe what your bot's policy is, and this will again be observed across all communications. So I've written in 4 bullet points here. The first says no fabrication of information. And this is something that we also will say in our basic prompt, and we'll show you that in a minute. But we're basically saying no matter where you're talking, don't make stuff up. And that's really, really important when you want to avoid hallucinations. Secondly, we have this fallback plan that says if you cannot answer a question, politely direct the customer to call the business or visit the physical location. It's really nice to have this fallback plan. Again, if you can't answer something, that's totally okay. We just want to make sure the bot knows what to do when it finds itself in that situation. Of course, it shouldn't be making stuff up. In the third point, we just have some professional boundaries. This is pretty applicable to all bots if you want. It just says be nice, be kind. This fourth one, that's bespoke to our use case. This says no price adjustments or haggling. In short, we do not want our bot to be able to change the prices and negotiate with users online. Whatever the prices we set are the prices. That should not be up to our bot to make these deals. Now, again, you can write whatever you want here. These will be enforced across all communications. But now the last thing you want to make sure you do is just enable the agent here at the top. And that means the policy agent will be running. You'll see it has a green little circle there. Now, if we refresh the emulator, now anytime we talk to our bot, it will be enforcing those policies. So welcome to The Hanger. We can still ask what's for sale, and this shouldn't change anything. And say now that we want to grab that knit sweater, but we don't want to pay $45. We want to pay $42. Can we get the knit sweater for a deal at $42? And let's see what our bot says. So it says the knit sweater is currently priced at $45, and their apologies, we cannot modify that price. And it explains that you can contact us if you want to talk about that price. Now, what you did see there is that you actually saw one output, and then it kind of flashed and then became a second output. But what you're observing there in the emulator is the first LLM response or first bot response, and then the policy agent enacts, and then it has the second response. Luckily, it looks like our prompt in our autonomous node is good enough that it didn't want to haggle in the first place, so it didn't have a huge change. But if your policy agent is kicking in drastically, you'll see a first message and a very different second message. In our case, they were both the same. Now, important to understand that the end user, the person chatting to your bot, they will only see the second message. We only get to see the 2 messages in the emulator, so you can kind of see what's going on. Now, the policy agent kicking in does add an additional level of response time, as well as it costs additional AI tokens. It has some AI spend associated with it. You can keep track of that. If we do look at the event debugger at the logs at the bottom, you see for this response, you see the amount of time and the amount of tokens spent for the response. And you see here at the bottom, this is the policy agent kicking in. It took about 1.5 seconds on top of the response, and it only cost about 3/100th of a cent. So it's not expensive, but it is worth noting that the policy agent does add a bit more time and a bit more cost. And it's up to you to determine whether that is worth it. I think the policy agent is fantastic, specifically if you're working in certain fields where making sure legal compliance is important. That is very, very strong. So just make sure you enable the policy agent and you should be good to go. All right, next up, let's talk about RAG, or Research Augmented Generation, which is a fantastic way to use the power of LLM, but rein it in on a very specific data set. And in our case, it's the data set we care about for supporting the hanger. Now, without diving too deep into the technical explanation of what RAG is, and there is a link in the description if you do want to know more, what we're doing here is we're basically taking the information we want our bot to know, putting it in a certain space. Then our bot will index it and make sure it's easy to search. And then we're basically saying, whenever we're asking a question, just look at that section of information we've put aside. So we're taking all the pertinent information about our business, we're putting it aside and training our bot to be an expert on just our business. Now, this is super important when you want your bot to be accurate, because your bot is not having to trawl through the entirety of the internet or the entirety of the data set it was trained on. All it's looking at is at the information that we chose, that we said was relevant, and it can look through that stuff really quickly. Now, luckily in Botpress, RAG doesn't require any additional steps. It is the inherent way that Botpress bots interact with their knowledge base. So all we have to do is upload the information we want our bot to know into its knowledge base. That tab, of course, here is at the left. You're probably pretty familiar with this. Now, when you create a bot, it will always have its default knowledge base. And in any knowledge base, you are able to upload websites, documents, tables. We can do a web search, rich text. This is functionally where you need to put your information your bot cares about. Now, to attach a website, so say you want to attach your company's website, you just type it in here and it'll index it and you can choose which pages are relevant. For our example, unfortunately, the hanger is not a real boutique, so I don't have a website to attach it to, but you just type it in here. Now, for documents, Botpress accepts a whole bunch of different types of file formats. We'll be talking in just a minute about what kind of file formats work better, but you can upload PDFs and doc files. Tables are just tables, so we already have a table up attached to our bot. This is a table we made called the products table, which has all that information our bot knows about what's in stock. Do be careful when you add a table, you have to add that table then to your knowledge base. So just a second, I'll delete my table here. And then once you made the table, which is still again in our tables tab, you can make all your tables here. You have to go to your knowledge base and you have to import the table. So once I go to the table section, I'll say I want to import the products table, and then the products table will be added to our knowledge base. If you've created a table but haven't added it to the knowledge base, your bot's not going to know about the table. You have the ability to attach a web search. And if you are building a bot for a business or a business you're supporting, I would advise against the web search. You should have access to all the information you need locally. So I would just upload that as opposed to trying to find that stuff through a web search. And you can upload rich text, which I have uploaded a rich text file here that has a bunch of the commonly asked questions about our business. And we'll talk about this again in a minute because this is really, really quite important. Now, as a final important step, you need to remember that anytime you have an autonomous node and you want your autonomous node to be able to interact with your knowledge base, you have to give it access to your knowledge base. Our node already does because it has this card here. I'm going to delete it, but just make sure if you want to access your knowledge base, add a card to your autonomous node called the search knowledge base, and you just want to add that in. Here, you can decide, again, which knowledge bases it has access to, the default knowledge base or all knowledge bases. And there's actually some really good use cases where you want to segment your knowledge base because certain nodes might not need to look through all the information you've uploaded. So again, the way that you set this up is dependent on your use case pretty heavily, but just remember, you need to add that search knowledge base card to your autonomous node. Now, this is your knowledge base. You're good to go. This doesn't require any additional setup, so RAG will just be working. And now our bot knows all of this information and it'll be an expert on our small business here. Now that we know how to add all our information to our knowledge base, I want to take a moment to talk about good formatting and making sure that our information in our knowledge base is formatted in a way that the LLMs that we're going to be using can parse quickly and reliably. This is very important. LLMs are just better at parsing certain types of information faster and more reliably than others. So it's in our best interest to make sure that everything we're uploading to our knowledge base is as easy and reliable to parse as possible. So as a first rule, long, unstructured documents, things like PDFs with images and text all mixed together, those are not the easiest for LLMs to parse quickly nor reliably. So if you can, avoid knowledge-based sources like that. If you have a PDF that's really important, I would try and extract the information and put it into something like a rich text document, and that will be something that's way faster and way more consistent to parse. That's a very good start. If you're looking at things like images, again, LLMs are not as great as parsing images as they are as words, as text. So if you're looking at things like graphs that have data in them, if you can represent that data in something like a table or even just in text files, that also goes a long way. So if this was an image that had all this information, you don't want it like that. You want it to have it like this in text and words. That's much easier for LLMs to work with. Now, on top of ensuring that our information is well formatted, we also want to make sure that we're not uploading too much information to our bot. Again, we want to make sure things are clear and concise. Our LLM will be indexing and going through all this information whenever you ask it a question, so we just want to make sure we don't have too much stuff for it to wade through all the time. And so what I would highly recommend is to be critical on what information you give access to your bot and what stuff is actually important for it to know. For instance, if we're attaching our website, maybe we should not attach all 5 years worth of blog posts we've been doing, but instead just attach the About Us page and our commonly asked questions and where our store is and that sort of stuff. Again, the more information it has to look through on any question, the more possible it is for it either to get lost or it to lose the response at some point. Now, speaking about keeping our information clear and concise, I mentioned earlier that we had uploaded this text document that just very cleanly contains 10 of the most commonly asked questions we're expecting our bot to be asked. Now, this is a really good workflow. I'd highly recommend having any FAQ questions, upload them separately. Don't have them buried in a PDF document. Don't have them so they have to be grabbed from a website. Just set these aside in a text document. Specifically, this document is in the Markdown format, which is a format I can highly recommend when you're doing anything to do with an LLM. Markdown is just really easy to work with, and it preserves structural clarity alongside semantic cues, and it's something that LLMs work very easily with. You'll notice here that this is in Markdown, but also commonly throughout the bot. Anytime I'm writing a prompt, it'll also be in Markdown. I cannot recommend it enough. Get familiar with Markdown. It is a very nice way to keep your bot on track. So these 10 questions are uploaded here, and this is now part of our knowledge base. So anytime we ask our bot one of these 10 questions, it should respond very confidently and very quickly because we made these questions as easy to access as possible. Our bot should have no problems. So let's ask about the return policy, for instance. So we say, if I bought something a week ago, can I still return it? And again, our bot is querying our knowledge base and it should be able to find any questions about the return policy very quickly. Yes, you can return an item if you bought it a week ago. Returns are accepted within 40 days and so on and so on. What are the store hours? So on and so forth. This is great. Again, anytime you find your bot responding to the same questions the majority of time, just get those aside in a very simple text document, format them well, and you'll ensure that you'll have no problems answering the basics. Now, our next point here is actually something fascinating. I only learned about this recently. And it's a way to make sure, again, if you're responding to the same questions commonly, you actually can go ahead and hard code those responses in their own workflow. So functionally, what we're doing here is we're using the LLM of our bot not to answer a question, but to understand the user is asking a given question. So for instance, if we ask the bot, what are the store's hours? We can have the bot understand, okay, the user is asking about store hours. And instead of looking up the knowledge base, it just says, okay, it's a store hours question. I'll send us to the store hours workflow. And in the store hours workflow, it just responds the store hours. So it doesn't have to look up the answer. It just has to understand what question is being asked. This is really interesting. And there's a very basic way we can use it. I'll be showing off now, but it's a kind of workflow to keep in mind. If you're responding to questions that require a lot of accuracy or very quick responses, this is a nice way. Again, we're using the LLM to understand intent, not to deliver the response exactly. So to set this up as an example, what I would do is I would make a new workflow. So I'm going to make a new workflow and I'm going to call this workflow just hours response. Cool. Now I'm going to go back to our main workflow, which is largely just our autonomous node, and I'm going to modify the instructions here. So I'm going to say here at the bottom, there's our core instructions that we added, and I'll add another core instruction here. And it says, if a user inquires about the business's hours or when the store opens or closes, send the user to the hours response workflow. So again, all our LLM is doing here is understanding the intent of the user. And once it understands the user's asking about hours, it'll send them to the workflow. So to make sure we can do that, we're going to add a card to our autonomous node. We're going to go find our hours response flow logic card. So how autonomous nodes work is that all the cards you add underneath it are just tools it has access to. And then through its instructions, it needs to understand which tools to use. So we're saying if a user asks about the business hours, use this hours response as a tool and send the user down that workflow. It won't answer the question specifically. It'll just understand, oh, the user wants to know about hours, send them down this workflow. That means in this workflow, we can just, with the standard node we have here, respond to that question. So this is a standard node. I'll just call it hours response. And I'll add a card. I'll add a simple text card. And in this text card, I'll just have the hours written in here. I'll say our current hours are, and then we'll make whatever up, Monday to Friday, Saturday. Now, obviously fill this in fully, but I'm going to leave this like this so we can tell when this shows up. So whenever, again, the autonomous node understands we're asking about the hours, it'll send it to this workflow, and this workflow will respond by just sending this text block. Now, as a final step here, I'm going to add another card, and I'm going to add a wait for user input card. And what this card does is just waits until the user asks the next question. And once the user asks the next question, it'll send that question out to the exit. Now we have to route the exit. So if we go back to our autonomous node, if we go to the hours response card here, we can turn on the exit node. And so basically when we get out of this hours response, once we leave the exit, I just want to wrap this back into the autonomous node. So whatever question was asked in hours response will be fed into the autonomous node and our conversation will keep going. That's all we really need to do here. And so now I'm just going to give this a refresh and I'll show you how this works. We can just say, hey, now as soon as we ask about the hours, it won't have to look it up in our knowledge base. It'll just send us to that workflow where we've hard coded our hours. What are the hours? And there you see our current hours are Monday to Friday, and then the Saturday and Sunday we didn't fill out. Now, if we ask another question, what's for sale? You'll notice that we've been sent back to the autonomous node and things will work just the way you want them to. Cool. Now, of course, we hard coded these hours in, which means that you have to be vigilant and change these hours if they make sense. You can also use an execute code card, or you can read values from a table. You can set this up however you want. I just want to highlight that this is a really interesting workflow, which again, you're not using your LLM to answer questions. You're using your LLM to understand intent. And based off the intent, you're firing a workflow and you've hard coded those answers into the workflow. I think this is just a fascinating workflow. And there's a lot of ways you can end up using this, but very accurate, very quick. Again, using your LLM as a router as opposed to a response engine. It's a very interesting trick. All right. So now our node can answer some questions. We have some hard-coded hours in. And one thing I don't think I've showed off is, again, not only in our prompt itself, but in our policy agent, we've made it very clear that if we ask a question that our bot can't answer, it won't try and make something up. It'll be very clear that it does not know the answer and we should contact the store. So say we ask something totally irrelevant. What is the second largest city in Slovenia? It should not know that because this information is not in the knowledge base. It says, I'm sorry, I don't have that information right now. Please call us or visit the store to help. That's great. Now, what I would advise here as the next step is we actually can track this information. We can record all of the questions that our bot is getting in and is unable to respond to. I think this is actually a really important process because there might be some inadequacies in our knowledge base that we should be addressing. If a lot of people are talking to our bot and not getting answers, there's probably a pattern there that we want to be addressing. So what we can do is, again, record these unanswerable questions. The way we're going to do this is we're going to make a new workflow. So I'm going to create a workflow and I'm going to call it unanswered questions. And similarly to what we did before is I'm going to edit the prompt of our autonomous node. And I'm going to add something here to the bottom of the core instructions. It says when you are unable to answer a question, transition to the unanswered questions workflow. That's simple. Again, this is just natural language, so it's pretty easy to work with. And of course, we're going to have to add another tool to our autonomous node. We're going to want to add that unanswered questions workflow. So again, we'll be sending to this. I'm going to do the same thing here where we'll have an exit node. And when we get to the exit of this, we'll loop back to the beginning and let's just set up our unanswered questions. So here in our unanswered questions, basically we want to grab the last question that came through the autonomous node that we weren't able to answer. And we're going to try and store it into a table of unanswerable questions. So first thing we're going to do is we're going to make a new table. So we'll go to the table section and I'll just create a new table really quickly. We'll call it unanswered questions. And we're just going to create one column and it's going to be of a string type and we're going to call it question. Cool. So we're going to be saving our questions in here. Notice that our table, we did not add it to the knowledge base. Now, I don't want our bot to know about the unanswered questions. They're for us behind the scenes to work with. So we don't have to do that, but that's how you would add things to the knowledge base or table specifically. And now what we want to do in the unanswered questions is that we want to have a question in and we just want to add that question to the table. So what we have to do first is grab the question we can't answer. And we can do that pretty simply. Here at the entry point of our unanswered questions, we want to make sure that it's looking for a variable. So we're going to create a new variable here. It's going to be of a string type. So it's looking for text and we're going to call it unanswered question. And we're going to add that. And now here at the entry, we're going to ask it to expect a variable. So if we toggle this variable, that means that we can send a variable to our entry and that variable will be passed into unanswered questions and we can use that in this workflow. So if we go back to our main here and we go to unanswered questions, we actually now can send an input variable. So we're basically saying, what do we want to send to this, which will be passed off to that workflow and that'll use that as the input. Now we know we want to pass in the last question the user asked, the question that we could not answer. So we want to just code that in. So we're going to click on this and turn on to manual mode, and we can just write the variable event.preview, which should be the last message sent in the chat. So this means, again, our autonomous node will be asked a question. It'll understand that it can't answer that question. And so then it'll be going to the unanswered questions workflow and it will send an event preview, which is the last thing that was asked. Now, once we jump to unanswered questions workflow, the unanswered question variable will be filled in by that event preview. And all we need to do is save that to our table. I'm just going to call this unanswered table saver. And we're going to add a card and we're going to use the card insert record. So we're adding something to a table. In insert record here, we have to choose what table we want to add to. We want to add to the unanswered questions table. Now the question we want to add, that's going to be a variable. So we click on this and we'll pick the unanswered question variable. And that should be it. So functionally, anytime a new question is asked that we can't answer, it'll be sent to this workflow. The workflow will insert it into our table, and that's kind of good to go. And then we'll be sent right out to our exit. And that should do it. And we can test this really quickly. So if we go back here and we do a restart conversation, so we can talk to our bot like normal. We can ask it for the hours. We can ask it for the products we have in stock. We're going to help you today. So let's ask a question we know that it can answer. So this is not in our knowledge base, and we know this is not in our commonly asked questions. So let's ask, are you hiring? That's probably an important question we want our bot to know, but it shouldn't be able to answer this. It does not know. So it says, I'm sorry, I don't have that information right now. Please call us. That's its normal response when it has a question it can answer. Now we jump over to our table. We can check our unanswered questions table, and you'll notice it logged the question, are you hiring, as something it can't respond. That's really good information. Now, the more our bot runs behind the scenes, this table will fill up with these questions, and it's up to us to use that information to either update our knowledge base or find out somewhere that our bot is failing. Maybe it's struggling to understand some intention when asking about a certain type of clothing. That will pile up here, and then we can use that to help make sure our bot is accurate. Now, notice it did say, hey, it did record the hey. I guess it thought that was an unanswerable question. That's obviously not great. So what we can go back really quickly is if we jump back to our workflow, we can maybe just update our prompt here and just change this. When you're unable to answer a question that is not a greeting, maybe that'll do it. Maybe it won't log the heys and hellos. So we'll go back to our emulator. We'll do a refresh. We'll say hey again, see if that gets logged. And maybe we'll ask something like, what's the parking situation like? Say we're driving to the store. Looks like we have nothing about parking in our knowledge base. That's important to know. So if we go back over to our table, it should log that. It didn't answer the hey, that's great. We'll just go ahead and delete this record. And then of course, what's the parking situation is logged in our question table. Now, of course, this table is totally hidden. It's not part of our knowledge base. It's just so that we, the person who built the bot that's supporting the business, we can have an understanding of what questions are not going through so we can update our bot to make sure we're accurate and responding to everything. The more things we can respond to, the more useful our bot is, and the less likely we're going to end up in a situation where we're making stuff up and failing to respond to things. Now, finally, and arguably most importantly, you're going to need good prompts. We haven't spent a lot of time talking about our prompt here on our autonomous node, but you cannot spend enough time writing a good prompt. And the better your prompt, the more on track your bot will be. There are tomes and tomes of information online explaining what good prompts should look like. And all I'll say off the top is, firstly, if you write in Markdown, I do think that helps a heck of a lot. But you'll notice just as kind of like boilerplate on every bot prompt I write, I will always include these two basic ideas. Firstly, I'll always make it clear to never make up information. This is something we reiterated in our policy agent, but that's always a good spot to be in. We also have our fallback plan here. If you don't have an answer, politely inform the customer and suggest how they can get help. It's always nice to have that. Sometimes you can make it clear to ask for clarifying questions, and that can help. But being concise, but also being thorough here is really important. I do want to warn, if your prompt gets too long, that can be detrimental, kind of similar to our knowledge base. The more information we're working with, the easier it is for the LLM to get lost. You want to be thorough, but also be mindful to be concise. A single sentence that just says help the user, well, your bot will be helpful, but maybe in ways that you're not intending to. I also want to shout out here at the top, we have a role. You are an AI chatbot that represents a small clothing business called The Hanger. I probably actually could have written a bit more here. This is called role assignment, and you give your bot context and explanation of what it should be doing. So it uses that to understand what probably falls outside of the context. So in our instance, it probably won't be giving information about people's health queries because that falls outside of its role. Role assignment is really important. You also notice at the bottom here, we do something called multi-shot prompting. I like multi-shot prompting a lot. We give examples of what we say are acceptable responses. So we have some questions and we have some responses. This is all in Markdown. Again, our whole prompt is in Markdown. Cannot recommend it enough. But multi-shot prompting is a good way to show your bot what responses should look like, and it uses that whenever responding. Very, very valuable. Our bot is only as good as our prompt. It is the most important piece here. So spend some time, iterate on your bot. Testing is also very important. So make sure once you get your bot working, try and break it. Spend some time in the emulator asking questions which you think are on the edge of what it should respond. And anytime you see a sort of response that does not make a lot of sense or is outside the scope of your bot, you can always edit your prompt to make sure you're on track there. In the description for this video, I've linked to the Botpress documentation about prompting where there's some really good examples. I can't recommend that enough. And with that, hopefully that helps and you're equipped with a toolbox of ways to combat and prevent hallucinations when it comes to your bot in Botpress. If you'd like to do some additional reading, I've linked to a blog article that Ben wrote up that talks about the whole field of hallucinations. It's very fascinating. If you have any questions, don't hesitate to hit us up in the comments. And if you want to join the bot building community over on Discord, the Botpress Discord server is linked in the description. And most importantly, happy bot building. Ciao.